Welcome back to our channel. Today we are discussing the scenario-based interview question for AWS Solution Architect. You can download the complete list of scenario-based questions from the link provided in the description. Let's understand the scenario first. You are tasked with designing a serverless architecture for a real-time analytics platform that processes a large volume of streaming data. The platform needs to be scalable, cost-effective, and capable of handling high throughput data streams with low latency. The data comes from various sources and needs to be processed, analyzed, and visualized in real time. Now, focus on the requirement. Our requirement here is handle high throughput streaming data with low latency, implement real time analytics, including data processing, transformation, and storage. Ensure cost efficiency by scaling resources dynamically based on demand. Provide a secure environment for data processing and storage. As a AWS solution architect, how should you approach this? Here are the below components you should select. First, start with streaming data ingestion. Use Amazon Kinesis data streams for ingesting high throughput streaming data. Implement Kinesis data firehose for automatically loading the data into other AWS services. Next, real-time processing and analytics. Use AWS Lambda for serverless event-driven computing to process and analyze streaming data in real time. Implement AWS Kinesis data analytics for real-time SQL queries and aggregations. Store real-time analytics results in Amazon DynamoDB or Amazon Aurora for low latency access. Data storage. Utilize Amazon S3 for cost effective and scalable storage of raw and processed data. Implement Amazon Redshift for data warehousing and complex analytical queries. Leverage Amazon Elasticsearch for full text search and visualization purposes. Scalability. Auto-scale AWS Lambda functions to handle varying workloads. Configure Amazon Kinesis data streams and analytics for automatic scaling based on incoming data volume. Use AWS step functions to orchestrate complex workflows and manage dependencies between serverless functions. Next is cost optimization. Optimize costs by utilizing serverless computing with AWS Lambda, where you can only pay for the compute time consumed. Leverage Amazon S3's cost-effective storage for data at rest. Use AWS Cost Explorer and AWS budgets to monitor and manage costs effectively. Security. Implement AWS Identity and Access Management (IAM) to manage permissions and control access to resources. Use AWS Key Management Service (KMS) for encrypting sensitive data at rest and in transit. Implement VPCs and security groups to isolate and secure components. Monitoring and logging. Utilize Amazon CloudWatch for monitoring Lambda function performance, Innes's data streams metrics, and other AWS resources. Implement AWS X-Ray for tracing and debugging distributed serverless applications. Set up CloudWatch alarms for automatic notification of any abnormal behavior. Next, disaster recovery. Replicate streaming data across multiple AWS regions for disaster recovery. Implement versioning and cross-region replication for critical data stored in Amazon S. This serverless architecture provides a scalable, cost-effective, and secure solution for real-time analytics on streaming data. It allows for dynamic scaling, cost optimization, and efficient processing of high throughput data streams. Adjustments can be made based on specific analytics requirements and data sources. Do you have any better solution in your mind? Please write that in the comment section. We can discuss it further. If you want to go for any AWS certification, you can find the current, valid, and updated questions tutorials in the description. All the best.